Hi everybody! Happy Container Conference and welcome to Happy Building with AWS Copilot. Today we're going to be talking about building, releasing, and operating your container apps on AWS with AWS Copilot. Before we go too deep into that, I want to do a quick introduction. So this is me, David Kilman. Hi, nice to meet you. And I will be your presenter today. And if at any point during this talk or in the future you have any questions about AWS Copilot, Amazon ECS, or just anything involving running your containers on AWS, feel free to ping me here at @CohiDave. I don't always know the answers, but I always know the people who do. So feel free to reach out at any point. And I'm actually from the Amazon ECS developer experience team. So our goal on the developer experience team is to help making building on AWS and ECS super delightful. So that leads me into the thing that we're here to talk about today. What is AWS Copilot? We're going to talk about this. We're going to talk about what AWS Copilot is and how does it help you. And that's going to be sort of what I focus on in my presentation. But we feel like a demo is really where you'll get to appreciate what AWS Copilot does for you. So in about 20 minutes, I'm going to hand it over to my friend FA, who's actually going to run you through a demo to build a fully production-ready application using AWS Copilot on Amazon ECS. So let's jump into it. What is the AWS Copilot? I mentioned a moment ago that I was going to tell you what it was, but I lied. Instead of telling you what AWS Copilot is, let's go on a journey that I think a lot of you have probably been on, and that journey is developing an application. So you and your friends are all sitting around building something super cool. You had an idea. Maybe it's a really silly idea. So I have lots of really bad, silly ideas. One example would be an augmented reality app that transcodes people's speech into emoji. I am a millennial, so I am super fluent in emojis. So I think this would be a super awesome idea. So what do? When we have an idea, we start to tinker, we start building, we get some code together. And we start prototyping. We start building on our laptop something really cool. Maybe we're like, oh, I'm going to use this cool new framework to try to build this. Or maybe I'm going to try out Rust for the first time. I'm going to do this in Rust because I want to be super fast. But we start building and we start researching and learning. And maybe we run into some bugs, so we start testing. We probably spend a lot of time on Stack Overflow or Google. But eventually, something starts to appear. Something that starts working appears. And we want to share it with our friends because maybe in the example of my augmented reality app, I'm actually not super good at machine learning. And it's super cool to learn and spend some time developing using machine learning. But if I want to make this emoji app a real thing, I want my friends to help me too. So I'll containerize my application so I can share it with them and they can work on it. And we can all work on this amazing, cool emoji translating app. And then one day, you run the build button or the test button or whatever button you have in your IDE and it works. You're like, this is amazing. I have this awesome application. It's finally come to life. So much sweat, so much labor, so much Googling, so much Stack Overflowing, so many weird cryptic error messages. But we have this awesome service running locally on our laptops and we are so excited. So what do we do next? I think the next step, at least that I like to take, is I want to have people actually use it. And as much fun as it is to sort of pass my laptop around to different people so they can try it, I want to put this on the cloud. So we have our code, and we've heard about this really cool container orchestration engine called Amazon ECS, which is a fully managed container orchestration engine, makes sure our application's alive. It supports AWS Fargate, so we don't have to have any hosts or EC2 instances. This is what we want, and we want to get our code from our laptop to Amazon ECS. But how do we do that? How do I set up my service to run on Amazon ECS? Well, the documentation is pretty good. We can go to the docs, we can read, we can learn, we can set things up, and maybe we'll even get everything all running on Amazon ECS. But this is not the only question that I have once I start wanting to have customers use my service, right? So how do I set up my service is one question, but there are more. What infrastructure do I need? I can't tell you how many times I have just Googled something, found the first answer on Stack Overflow, and just copy and pasted it into my code, and it worked, and I never touched it again. That's okay for code, no judgment, I do it all the time. But for infrastructure, it's a little more scary, right? We want to make sure that our infrastructure is living up to AWS best practices. We want to make sure that it's scalable, and most importantly, we want to make sure it's secure in the future, so that our customers who are using our cool emoji app don't have to worry about their security. How do I develop my service with my team? We talked a little bit earlier about having this cool set of team members who know a lot, have different expertise, and I want to make sure that in the future I can work with them to develop my application in a way that we don't have to coordinate too much. How do I add and manage more services? A lesson that I think a lot of folks who've run services have figured out at some point in their career, or they will figure out at some point in career, is that monoliths are really awesome and convenient, and they are the right answer sometimes, but we want to be able to also support lots of smaller services, so we can break our application up into multiple different services. How do we set ourselves up so that we can do that in the future easily without having to require a huge re-architecture? How do I add a database? This is a super simple question, but it's a legit question. How do I add a database to my service? A database that's secure and a database that will scale to meet my needs. So there's a lot of questions around how do I actually build this application on AWS. But beyond just building our application, how do I deploy them? How do I actually make sure that, I can always just run some sort of deployment command, maybe do it through the console, but how do I do it in a scalable way? How do I make it so as I add more services, or if I add more complexity, that our deployments are standardized? How can I test without affecting my production customers? I am absolutely guilty of SSHing into prod and fiddling with values and to see if things will work. But that isn't a super scalable solution, and we don't always want to be able to use our customers as our guinea pigs. So how do we make it so that we can test our actual service in AWS in a test environment that's isolated from our production customers? How do I scale these services? The last thing you want is to have a super successful, awesome app that's running, and then suddenly it stops working and you don't know how to scale it, right? So we want to be able to answer that kind of question before we end up developing it, before we give our customers the service. And finally, what do I do when something's wrong? How do I figure out what's wrong? How do I debug my application once we're running on AWS? So these are a bunch of questions that, there are tons more. You probably have your own set of questions. These are questions that I just think of when I'm starting to deploy my application to the cloud. So what can we do about this? So I think one thing that we can do is maybe distill these questions into 3 kind of themes. How do I build, release, and operate my applications? And this is where AWS Copilot comes in. AWS Copilot is a new command line tool from the Amazon ECS developer experience team that helps you answer those 3 questions: building, operating, and releasing your service on AWS using Amazon ECS. So today I'm going to walk you through some of the ways that AWS Copilot can help you do that. And remember, FA is going to actually give you a demo of doing all of that, which is super cool after I finish talking. So let's jump into it. Building, releasing, operating. Let's see how AWS Copilot can help us build our application. So here are some of the questions that I pulled from earlier. How do I set up my service, and what infrastructure do I need? This is usually the most immediate need that folks who are trying to deploy their application to the cloud get. How do I do all this, right? What are the right tools for me to deploy my service to AWS? And there's a ton of infrastructure available to you as a customer of AWS. AWS offers these super powerful, scalable, secure pieces of infrastructure to help you build your service, but sometimes it can be a lot, right? And we realize that you don't always want to have to deal with just the infrastructure. You actually want to you're thinking about your service in terms of the architecture of it. I want this service to run on the internet and it takes requests from the web and it can scale. Or I want this service to be private and work as a kind of worker service in the background when it can't be reached from the internet. So we know that you think of your service in terms of architecture rather than infrastructure, and Copilot reflects this. So when you first start with Copilot, one of the first questions we ask you is, Copilot will ask you a bunch of guided questions to help you set up your service. And one of the questions we ask you is, what type of architecture best represents your application? And this architecture actually translates directly into a set of infrastructure resources. So as an example, if you said, I want my service to be a load balance web service, i.e. a service that serves customer traffic, if you select that, Copilot will actually set up a bunch of resources for you, including your VPC, the subnets for your VPC, security groups for your VPC to make sure that you don't have any unwanted traffic coming in, an ECS cluster, and an ECS service to actually manage your code and make sure your containers are healthy, Fargate tasks to actually run your service on so you don't have to manage any EC2 instances, service discovery to make sure that you can actually communicate between your applications without having to go on the internet, ECR repositories to store your images. So when you do a Docker build, Copilot will actually do that for you. It'll build and package your application and push it to a ECR repository for you. And in this case, we're doing a load balance web service, so we'll need an application load balancer. An ACM certs if we're doing HTTPS and you have your own custom domain name. So there's a bunch of infrastructure that you actually need. And Copilot wraps all that up into an application architecture pattern for you. So you don't have to worry about provisioning all these individual resources. You just tell us what type of architecture you want, and we'll use Amazon best practices to help you build a service that is going to be secure and scalable. So the infrastructure is a super important part, and we're super excited to help you get through that. But as we alluded to earlier, this is definitely not the only thing that you're going to have to worry about when you're setting up a service on AWS. There's more. How do I add and manage more services in the future? I want to have a microservice architecture from the get-go, or I want to start splitting my monolith up into lots of smaller services. And how can I develop my service with my team? We've talked a lot about individuals being able to build a service, but how do you work with a bunch of different teams to help build your application? So the way that we think about this in AWS Copilot is your application is more than just your one service that's running. Your application is actually all the services that you need to accomplish your goal. So in our emoji application, for example, we might have a couple of different services that help get to that end goal of having an AR application that live transcodes human speech to emojis. By the way, if someone actually invents that and runs this talk through it, that would be delightful. But in Copilot, we think that one application can consist of many services. Of course, you can just have your one service. That's totally normal. I have a bunch of Copilot apps that only have one service. But by being able to have services compose your application, it helps you scale in the future. So let's take an example. In this example, I have the next big thing app. Like I said, this could be anything you choose. I'm thinking that my emoji transcribing service is really going to be the next big thing. So after this talk, that's what I'm working on. And maybe it's composed of 3 different services: our website, an admin portal, and a worker service. And you can kind of see how the architecture patterns help describe what these services are going to do, right? So our website is a load balance service, and so is our admin portal. This sort of indicates to me that these are going to be front-end services. I'm going to be able to access these from the internet. But my worker service is a back-end service. It doesn't have any access to the internet. It's private. So this is super cool because that way, with Copilot, you can view all of these services at a glance just from your one application. So that's great, but we talked a little bit about this worker service being a backend service. How do we get it so that our website or our admin portal can actually call it? Well, that's one of the things. Once you start adding more services to your application, you start running into more problems. And AWS Copilot tries to look ahead a little bit and use common best practices to make those problems, to foresee those problems a little bit in advance and to help you out. So for example, in this case, when we have our admin portal wanting to make a request to our backend service, it can't go on the internet. Our backend service is private. So we have service discovery built in. So what service discovery lets you do is you can address your service using a common name. So in this case, it's the service name plus the application name plus .local. So our admin portal can call worker.thenextbigthing.local to send requests to our worker service. It never goes over the internet. And this is all by default. So the website can also make the same request and vice versa. The worker can make a request to the website service without having to go on the internet. So that's just sort of a nice thing. AWS Copilot understands multiple service applications and tries to help you architect for that by building things in like service discovery. But having lots of different services has its own problems. It's harder to manage. So why would we maybe think about splitting our services up into microservices like this? Why not just have one monolith? Totally could. That totally makes sense. But there's a couple of benefits of having lots of microservices, right? they're individually scalable, they're individually deployable. But one of the things that I think is most important is that different people can work on these services independently. There's no like centralized coordination that like a monolith would have. So one of the benefits that AWS Copilot brings with this microservice architecture is that it scales to whatever developer architecture or team architecture you have. So if you're just a solo developer, like I have lots of AWS Copilot applications with lots of services in it, but you can scale it to your team. So you can have a front-end team that works on the website, or a tools team that works on the admin portal, and a back-end team that works in the worker service. And totally up to you how you want to like organize your team, but the point is that AWS Copilot will meet you how you architect your teams. And the only requirement is that these different folks have access to the same AWS account that your Copilot application was created in. And then they can add their own services to the application, they can deploy them, they can scale them totally independently. So another question that you might have is, well, how do I add a database to this application? You know, we have service discovery, we're able to spin up new services super easily. We have different teams that are working on different services. But like, how do I make it so that I can add a database to like my website service or something like that? Well, a really common pattern is maybe spinning up a new service. You could totally spin up a backend service for your database that's running some database software, maybe Cassandra or something like that, and it would work. But you know, managing a database is pretty tough. Tough enough that AWS has lots of different teams that do that for you. And we have some really cool databases built into AWS, like DynamoDB or Aurora RDS or S3, things like that. And we want to make that super easy to use. So while you could spin up a backend service using Copilot just by running Copilot init and spinning up a new service that's running your own database software, we wanted to make it so you can use AWS databases as well, because that'll save you a lot of time and a lot of headaches. So in AWS Copilot, we have this cool tool called the storage command, and you can actually just use from your command line run storage init, and we'll provision either a DynamoDB table, an S3 bucket, or an RDS instance soon for your database. And what's really cool about this, and FA will show it to you later, is that like we're not actually creating a database as soon as you run this. We're actually just writing some configuration to your workspace file, to your local Git repo that has a configuration for this DynamoDB table or this S3 bucket. And when you run storage init, we'll run you through a couple of questions, like in your Dynamo table, what is your hash key, what's your range key, what are their types, and we'll generate a template and put it into your directory. And the next time you deploy your Copilot application or your Copilot service, it will create that DynamoDB table for you. And this configuration is totally yours. You can edit it. It's just CloudFormation. So if you have more advanced needs, if you want to add, I don't know, like a global secondary index to your DynamoDB table or set up website access on your S3 bucket, you can totally do that because that configuration lives in your code. We just want to make it super easy to get started with these tools. And since Copilot is aware of sort of this application that you're developing in and these services in your application, when you add a Dynamo table to a service, we want to make we know that your service is going to need permission to access that DynamoDB table, right? So one of the things that we also do when you run this command is we generate a policy for you, and that policy will give your service the ability to call DynamoDB. Again, it's totally your policy. You can edit it, but we use AWS best practices to sort of guide you in what this policy will look like. So that was building. We talked a lot about building our application, scaling it to meet your team's needs, service discovery, adding multiple services, adding multiple databases. But now that we have all these things, how do we deploy it? How do we release our application? So I think the most important question is how are we able to test our services without affecting our production customers? I'm sure a ton of you are able to just like write code that just doesn't break. I am not. Ask any of my coworkers. I write bugs all the time. And what I want to do is I want to be able to test that in AWS without affecting my production customers. So I can't just deploy to prod. Instead, I want to have sort of my own like pre-prod environment. This environment will have all my services in it. It'll have all the infrastructure for my application, including like my load balancer in this example. And I want it to be kind of close to me. I live in Seattle, so I want to create all these services in US West 2. And I want it to be in my development account because my development account I have full access to, right? I can go in, I can put fake data into my DynamoDB tables. I can just delete my DynamoDB tables. I can just poke around. So in Copilot, we call this sort of encapsulation in an environment. And in this case, I want a test environment. And this is the environment that I'm going to deploy new code to. So I want to deploy my new awesome change that makes all my emojis upside down or something crazy like that. And I can deploy it to my test environment, which is running a copy of all of my services without affecting my production customers. And I can set up a totally separate production environment. And in this case, maybe I want it to be in US East 2 because I have a lot of customers on the East Coast. Or I want it to be in a production account where I have less, shall we say, wizardry permissions. Maybe I have only read-only permissions in the production environment. But I want to be able to run my test code in my test environment. And when I'm happy, promote it to my production environment. And in Copilot, you can do this. All you have to run is Copilot environment init, and we'll start asking you a bunch of questions about how to configure your environment. And each environment is completely isolated from each other. They have their own VPCs, their own copy of the infrastructure, so you can go wild in your test environment. So now that we have, we've talked a lot about adding lots of services. Copilot lets your one application have lots of different services. You can have lots of environments in your application, a test environment, a production environment, which has a copy of all of those services. How do we deploy these services? So in AWS, we take a lot of pride in our release process. The reason we do is because it helps us get the best of both worlds. We're able to iterate quickly, we're able to deploy and test our code, and then once we're satisfied with that, it gets automatically pushed to our production environment. So no one has to do any manual deployments. And we want to make that super easy for you too. So let's talk about kind of what an ideal deployment workflow might look like. So we'll have sort of a pipeline, a source, build, test, and production pipeline. And what we really want is rather than running Copilot deploy to deploy all of our code to one of our services, we just want to push our code to our GitHub repo or our source repository. And then our coworkers or our friends or our teammates can review it, give feedback, and then once they approve that change, it can automatically be merged in. And we want, when that change is automatically merged into the repository, to trigger a build. And we want this build to run all of our unit tests, all of our style checks, our linters, and we want it to package our code up into a container image and push it to ECR. And once that build is complete and it's passed, we want to deploy to our test environment. And our test environment, like we said earlier, is where we have all of our experimental code. We can run our automated testing, and maybe our automated testing will pass, or we can do manual testing, or we can go in and actually poke at our website, our test environment's website. And once we're happy with that, we want it to be deployed to our production environment. And we want all of this to happen without too much human interaction. We don't want someone to have to shepherd a change out and to watch it and make sure that it made it to the test environment and it made it to the production environment. So with AWS Copilot, we believe continuous delivery should be easy because we think it's super cool. Like we said earlier, you do awesome work, right? Like you're thinking of these cool ideas, you want to build them. We want to make doing the right thing easy. Continuous delivery will save you so much time and so much headache, but it can be a pain to set up. So in Copilot, we make it super easy. All you have to do is run Copilot init, and we'll ask you a series of questions and sort of like, how do you want to deploy your code? Do you want to deploy to your test environment and then your production environment? Do you want to deploy just to your test environment? And what that will get you is it'll give you an AWS code pipeline, and that code pipeline will be configured to trigger once you push to a certain GitHub repository and branch. And that's super cool because this does a lot of heavy lifting for you. So you don't have to worry about setting this up. You don't have to worry about the account or the regions that your environments are in, your services are in. And you can just focus on building your application. And this is really the only way to scale yourself once you're building lots of microservices that are deploying to lots of different environments. So that's how Copilot makes releasing your application pretty easy. And we've done all the cool stuff, right? We've built our service, we've added lots of microservices, there's service discovery, we added databases, we worked with a team, we set up a test and production environment with automated testing and a release pipeline that goes through. And yet, sometimes we still need to operate our service, right? Sometimes bad changes get through. So what do we do when something's wrong? This is going to be a little intimidating at first, right? There's a lot of things in the AWS console. There's CloudWatch, there's CloudTrail, there's a lot of different options for you when you're trying to figure out when something goes wrong. And you just kind of want to dig in quickly and see what's happening to your service. So let's say you open up your service one day and you hit the URL and it's taking too long to load. The first thing you can do is run Copilot service logs. And what this will do is it'll pull down the logs for your service and you can actually tail them. So maybe you hit that refresh button a couple of times. And I say, for me personally, debugging, 9 times out of 10, an exception or an error will show up in the logs. And you can go back and you can look historically and see kind of when these errors started, all from your command line. So this is what I use so often. It's just right there to see what's going on with my service. But sometimes your logs don't always have your information, right? Sometimes you need more. So we also have another command called Copilot service status. And what service status will do is it'll show you sort of a high-level health of your application, how many tasks are running, what they're currently configured for. But what's really cool about service status is if you have any alarms associated with your service, it'll show you the status of those alarms. So one common alarm that I often set up with most of my services is something like a memory utilization alarm. I do a lot of Java development, so I understand sort of memory pressure can affect the performance of my application. So if I have an alarm that says, trigger or fire when my container is at 90% memory utilization, that really helps me pinpoint quickly what's going on with my application. And something like a slow page load, that is a totally reasonable place to look. So maybe we found out that through the service status command that we don't have enough memory for our application or our service that's running. What do? How do we configure our service? How do we fix that? Well, when you run Copilot init and it sets up a service, it also creates a file locally for you. That local file is called your manifest. And this manifest is just another file in your service. So nothing special about it. But it contains all the most common knobs that we've seen customers use when they're developing services on Amazon ECS. So in this example, you can see this manifest file is for our front-end service, and it has a bunch of different configuration. But what's most interesting for us in terms of operations is this resource configuration at the bottom, the CPU and memory that we have allocated for our service. So this is super easy. If we realize that our Java service is maybe does not have enough RAM, in this case 512 megabytes, we can just really quickly double that to 1024, a gigabyte. And this is, like I said, this is just another file. There's nothing special about it. So when you do a Copilot deploy to your service, Copilot will actually take into account this configuration file and expand your service's tasks to all have a gigabyte of memory. Or even better, rather than running Copilot deploy, if you have a continuous delivery pipeline set up, you can just git commit and push this, and then your pipeline will deploy this change to every environment. And all of your environments will be upgraded to have a gigabyte of RAM. And maybe you're saying to me, David, that sounds super cool, but my test environment is fine, and I don't necessarily want to have my test environment have a gigabyte of RAM because I just don't really need it, right? I really only use it when I'm running tests and it doesn't have any real load. So Copilot totally gets that, and that's why in this configuration file, you can actually specify environment-specific configuration. So you can say that in our production environment, I want to have 512 CPU units or a gigabyte of RAM, but only for our production environments. In our test environments, we'll keep the default configuration. And like I said, all you have to do is deploy this file, just Copilot deploy, and that configuration is applied. So that's a little bit about operating your service with AWS Copilot. And I could go on for so long about a lot of the cool features that we've built into AWS Copilot. I'm super excited. I love this tool. I don't want to gush too much, but I think it's really helpful in just taking some of the undifferentiated heavy lifting about building, releasing, and operating a service out of the picture. I could talk about this for a long time, but I think rather than do that, I'm going to hand it over to FA, who's going to run you through a demo. He's actually going to build something for you. It should be really fun. Thank you so much for watching. enjoy the demo. And remember, if you have any questions about AWS Copilot, Amazon ECS, or just running your containers on AWS, feel free to reach out to me on Twitter, and I'd love to help you. Thank you. Bye.
Thanks, David. Hi, everyone. I'm Efe. You can find me on Twitter at Efe Caracas. And just like David, I'm a developer on the Amazon ECS Developer Experience team. Today, I'll be giving a demo of the AWS Copilot CLI, mostly focused on the getting started experience. So how do I take a container that's running locally and upload it onto Amazon ECS and AWS Fargate? Once we understand what the CLI does under the hood, we're going to take a look at some commands for growing your application. So how can I add a new service to my application? How can I add a new environment, such as a production environment? Or how can I set up a continuous delivery pipeline? Awesome. So let's start building. I'm going to switch over to my terminal really quick. And you can see that I have a Git repository named Copilot's World Map. From the root of my repository, I'll type tree. You can see the files that I have in the repo. So I have my Docker file, a bunch of Go files, an index.html page. So you can guess that I'm going to build a Go web application today. I'll type Copilot to get the help menu. It tells me that the CLI helps me launch and manage applications on Amazon ECS and AWS Fargate. So under the CLI, we have a bunch of commands. You can see some of the concepts that David talked about earlier, such as applications, environments, and services. So we have separate commands for each one of these concepts, and they're under the category develop. But today, I'm mostly interested in the getting started section. So I'm going to run the Copilot init command. Copilot init. Awesome. So you can see that the CLI tells me it's best to run this command from the root of my Git repository, which is exactly what I did. Then it welcomes me. It's going to ask me a bunch of questions to get me set up with an application on Amazon ECS. And an application is a collection of containerized services that are operating together. The first question that the CLI asks me is the name for my application. I'm going to give the same value as my Git repository, Copilot's World Map. And we'll give an explanation of what this application is pretty soon. The next question is which service type best represents my architecture, right? So just like David said earlier, we like to think in terms of architecture and not individual infrastructure resources. I type question mark to get a better understanding, and it tells me that a load balanced web service is a public internet-facing HTTP server that's behind the load balancer. And a backend service is a private non-internet-facing service. Today, I know that I want my service to be accessible from the internet such that everyone will be able to use it. So I'm going to choose an internet-facing HTTP server that's behind a load balancer. Right? So I'm going to choose load balanced web service. I'm going to give the name for my service to be just front end. And then the CLI picked up that I have a Docker file that's available in my Git repository. So if I had more than one Docker file in my repo, it would have been listed here as an option. But in this situation, I have a single Docker file, and I choose the Docker file that's at the root. Okay, great. So we're starting to set up a load balanced web service named frontend in my application, listening on port 8080. And looks like it's starting to create some infrastructure resources. So let me switch over to the browser so I can give a demo of what this application looks like. I have the container already running locally, and it's telling me that it's a visualization of all the countries that copilots like you and I have been around the world. Right? So if I click on any one of these countries, the visualization should get updated. So I'm going to start, for example, clicking on France, and then I should see that the visualization gets updated and tells me that copilots have visited 3 countries so far. Pretty soon I'm going to deploy this onto Amazon ECS and Fargate, and in that situation, if someone else comes to the application and then they click on Spain or France, their visualization will be updated for everybody, and then the counts will also get updated. I'm going to switch over to my IDE, and we'll be able to take a look at the Docker file here. You can see that I have a simple Go application, just like mentioned earlier. In the Docker file, we don't do anything too fancy. We just build our binary. We copy the necessary files, such as your template, the HTML template. We run the binary, and we expose port 8080. Earlier in the terminal, you might have noticed that the CLI picked up that port 8080 was exposed. That's because the CLI parses this Docker file, and if we see an expose instruction, we automatically inject that we'll pick it up and then we'll inject that into our infrastructure as code file. Awesome. So looks like it created the infrastructure to manage my services under this application. It says that it wrote the manifest file for my service front end at this particular location locally. And then it created the ECR repositories for my front-end service. I'm all done for local development. The next question is asking me if I want to deploy this to a test environment. And the answer is always yes. I always want to deploy my service to a test environment. So I'll pick yes, and then it's saying that it's proposing the infrastructure changes for the test environment. So it's going to get started with building a test environment. Let me quickly kill my local container. I'm going to switch over to the IDE and we'll take a look at some of this application code. So earlier I did not have a Copilot directory. When I ran Copilot init, this new Copilot directory was created, and under it we have a front-end directory that's for my service. So you saw that the manifest file was created. It should be under this directory, and the manifest file is really our infrastructure as code file. So like we mentioned earlier, we like to think in terms of architecture. So this is really architecture as code, right? So this is the minimal configuration that you would need for a load balanced web service. So I have the name of my service described here. It says front end. It has the type of my service, load balanced web service. Then it has some basic settings that's necessary for the load balanced web service, such as the location of the Docker file, which port is exposed in my Docker file. I could change that if I want to. The path that the load balancer will listen on. So if it will listen on / and then it will forward all the / requests to my service. The container size that I can specify, and the number of tasks that should be running in my service. We create everything with minimal settings. So we have a CPU of 256 and memory of 512, and a single task that will be running in my service by default. We have some optional fields that are also available, such as variables field for environment variables. So you can inject environment variables. We have a secrets field. So if you have any secrets that is stored in AWS System Manager parameter store, these secrets will be injected as environment variables to your service. And finally, we have the environments field to do any environment overrides. So let's say that I have a production environment and I want my service in my production environment to be more resilient, right? I want tests to be of minimal cost, but I want production to be resilient. So I can say for prod, I want a count of 3 so that my service has more redundancy and it should be handled like a task failure. And I can override any of the fields that is listed above. So I could change the CPU and memory settings as well, for example. Great. So let's switch back to the terminal, and you can see that it started creating the infrastructure for my test environment. Just to give a recap of what an environment is, it's really just a deployment stage, like David mentioned earlier. So all your services, in an environment, we're going to create the infrastructure resources that will be shared across services. So for example, if I have a backend service as well as a front-end service, they will share the same ECS cluster in my test environment. So under a test environment, these are all the resources that we are creating. We are creating a virtual private cloud that's on 2 availability zones to hold your services, right? So under the VPC, we have our internet gateway, we have public subnets, private subnets, the routing tables. So these are all the networking and security level configuration. Then we have our ECS cluster that will hold our service, as well as the application load balancer. So if I have an API service, for example, that's also behind the load balancer, that will share the same load balancer in my test environment. I switch back onto the code just to get a little bit more understanding of how our service works. So I listen on port 8080, and I'm just going to create an HTTP server. Let's look at what the server does. So I just create a brand new server, and you can see that I'm listening on different paths, right? By default on /, I'm just going to render the template, the index.html page. So this is the visualization that you saw earlier. We have a text blurb as well as the chart that will be displayed in this HTML page. Switching back to server, we can see that I'm also listening on /visits. So if I get a GET request on /visits, it's going to call the handle visits handler, and it's going to display all the countries that's available to me under that have been visited. I can also make a post request to /visit/France, for example, and that will trigger the handle visit country handler. If I press on this, we can see that we are saving the country that I visited in my database, so the number of visits will be incremented by 1. Okay, great. So I switch back to the terminal. You can see that the test environment was created, it's all complete, and it moved on to the next step, saying that it's linking my account and my region, US West 2, to application Copilot's world map. So there is no magic with the CLI, and I'm going to switch over to the browser over here to explain how we create all these resources with Copilot. I go to CloudFormation, and every resource that's created with the Copilot CLI maps to a CloudFormation stack. So for example, for the test environment, we'll have a stack that follows the naming pattern, your application name dash your environment name. So Copilot's world map dash test. I'll click over to this to my test environment stack, and we should be able to see the resources that have been created there. So I'll go over to resources, and you can see that these are the same resources that was listed earlier in my terminal, such as the ECS cluster, all these networking related configuration that's related to the load balancer, right? The target group, the HTTP listener, the public subnets, the load balancer, the VPC, as well as the service discovery namespace that will be shared between services in your application. Okay, so the linking step itself maps to the stackset instance. And what this is, it's going to create the ECR repository for my service. So it has created the ECR repo for the front-end service. And underneath, there's also the KMS key and the pipeline built artifact bucket. So these are resources that are really needed for the pipeline that we'll set up eventually with our application. So these resources will have already been created, and the pipeline creation itself should be really quick. So I'm going to switch over to the terminal now, and we can see the next step. It linked my account, and then it says that it started building my container image. Great. So the next step is for us to build our container image and then push that onto ECR. You can see that it's on step 6. Right now it's downloading the dependencies, and it's about to push to ECR. So I'm going to switch over to the ECR console really quick so we can understand how we create repositories with Copilot. For every single service that's created in your application, you'll get a separate ECR repository, and we follow, again, a naming pattern. So the repo name will be Copilot's world map, the application name / your service name front end. If I have more than one service, that will get its own ECR repository. So if I had a backend service, that will get a /backend ECR repo. And if I had more than one environment that was in a different region, let's say I have a production environment that's in US East 1, then the US East 1 version of the ECR will get a separate repository that will be in US East 1. So you get a separate repo for the same service for each region that your service is in. If it's in Oregon, you get one repo in Oregon. If it's in US East 1, you get one repo in US East 1. And awesome, so if I click on the ECR repo, we can see that it was pushed. So I can see that the image was built, and we pushed it to ECR, and we can see the image appear over here, just like we expected. It moved on to the next step, which is deploying our front-end service to the test environment. So if I go to the CloudFormation console, I should expect a new stack there to describe my front-end service. Yep, just like expected, I can see that we have a new stack that's being created. It follows again the naming pattern of your application name dash your environment name dash your service name front end. I'll click onto it and I'll go to resources so we can see what's being created. So these are all the resources that you would expect for a service to have, right? So it has all the resources that's needed to connect your load balancer to your service. It has the ECS service that's being created right now, the task definition, the task role, and if I refresh this page, the resources itself should be updated over time. So I'm going to switch over to the ECS console, and we should be able to see a cluster here. Yep, so this is the cluster that was created for my test environment. And you can see that under the test cluster, I have a single service right now. That's expected because we are only created the front-end service. It has a single service that's pending one task. So the task itself is still not running yet. I'll click onto the cluster, And we can see the front-end service with the desired count of 1, which matches the count setting that we saw in the manifest file earlier, but it's still not running. Let me click over to the service and go to the tasks tab. And we can see that the task is in provisioning state and is still not running. So this is a good time for us to talk about some of the operational commands that's available to you with the CLI. So I'm going to switch over to my other tab, and I'm going to run Copilot again so that we refresh ourselves with the commands that is available to us. You can see that under develop, I have the environment, application, and service commands. And since I'm trying to get operational work done for my service, I'm interested in the Copilot service command. So I type Copilot service to get the commands that's available to me under the service namespace. And the last two commands are relevant to us for doing operational work. So I'll type Copilot service status to get the health of my service. It's saying that it's showing the status for the front-end service that's being deployed to the test environment. Right now it's active, but it says 0 out of 1 running task. One task is still pending, right? So that means that my task is still not up. It's still not running. It updated, yep. So let me go back to the console. Let me refresh really quick. Awesome. So it looks like the status now of my task is running. So if I run service status again, it should say 1 out of 1, and everything should be running at this point. Awesome. Yay. So another command that we saw earlier that was available to us to do operational work was the service logs command, right? So if I type Copilot service again, you see that logs is available to me to display logs of a deployed service. So I type Copilot service log -- help or just -h to get the help menu. And you can see that I have a bunch of flags that's available to me to filter on these logs. Right now, I'm just going to type -- follow to tail my logs. Awesome, so the service is up and I can see my logs that's being displayed for the service. It says that the deployment is done for the front-end service, and it gives me the URL that I can use to access my, my web application. So I'll copy this, paste it onto the browser. Yep, our application is live. So you can see the visualization itself. Right now, no one else has used the application, right? So if I go ahead and start pressing on France, on the United States, you can see that my visualization is being updated in real time. And if I switch back to the terminal, go to the logs, you can see that the logs are trickling in, right? So it says that France is visited with a count of 1, the United States is visited with a count of 1. I'll press on France again, and then the logs should come in saying that, yep, France has a visit count of 2. So we went over the getting started commands, we went over the operational commands that's available to you with the CLI. Now let's take a look at how to grow your application with the Copilot CLI. So I'll type Copilot again onto the terminal to see our menu. All right, and in this situation, I'm mostly interested in the environment command. So I'll type Copilot env, and I can see that I can create a new environment, I can list all of my existing environments, or I can delete an environment. So I'll type Copilot environment init to create a production environment, for example, right? Prod IAD will be my name, and I can choose which profile I want to use to create my production environment. So if my prod profile points to US East 1, then my environment will be created in US East 1. I'll stop this for now, and I'll show how to create a new service. So I would type Copilot service init to create a new service, right? So let's say that I want to create a backend application, right? Earlier we saw that I'm listening on, /visits, /unique visits, all these different paths in the code base. Yep, so I'm going to show that really quick in the code, like handle visit country is writing to the database. We have all these different paths right now that is contacting my database. If I want to refactor this code and move it to its own service so that no one else from the internet will be able to access it, I would choose a backend service, and I would name it backend for my service, for example. Awesome. So the last command that David talked about earlier is pipelines. So how do I set up a continuous delivery pipeline for my application? And I have 3 commands available to me: Copilot pipeline init to create a new pipeline, Copilot pipeline update to update my continuous delivery pipeline, and then pipeline delete to delete my pipeline. Great. So let me switch over to the code really quick, and just as an example, let's say that I want to change my database, instead of being an in-memory database, to be a DynamoDB table. Another command that's available to me, I can choose how I want to do this deployment, right? I can either do a manual deployment after I've done my code changes, right? So I could do git push to trigger the pipeline, or I can do a manual deployment with the Copilot deploy command, right? So I have two options when I'm releasing my service. If I have the pipeline already set up, then I can do git push. If I want to do a manual deployment, Copilot deploy. If you want to add additional resources to your service, right, I can create add-ons. Add-ons are just CloudFormation templates that you would inject to your service. So in this situation, I type Copilot storage init to create a storage add-on. I'm going to choose DynamoDB to create a DynamoDB CloudFormation template for me. I'm going to name my DynamoDB table travels. I'm going to put the partition key as country, and I'm just going to select string, and I don't want a sort key, right? So it says that it created the add-on CloudFormation template at this particular location locally. It even tells me how I can connect to my database with this particular environment variable. So travels underscore table underscore name will be the environment variable that I can use to connect to my database. And if I look over to my IDE, you can see that the travels CloudFormation template was created for me. So that means that any additional AWS resources that you might want to add to your service, such as a database or a queue or a stream, you can create your own CloudFormation template there under add-ons, and it will be picked up as a nested stack. Awesome. So before we end the talk, I just want to talk about some of the additional work that we are doing that's going to come in the future. One thing that we want to do is importing resources to your environment, right? For example, if you have already an ECS cluster, if you have already a VPC that's available to you, you'll be able to import these resources to your environment. An additional route that we're exploring right now is being able to use CloudFormation or the AWS CDK directly instead of our manifest file. So for example, if I don't want to use my manifest file anymore and I just want to write CloudFormation instead, you'll be able to do that. Some of the additional links that might be helpful for you if you'd like to learn more about the Copilot CLI is our repository is completely open source, so you can access it on github.com/aws/Copilot CLI. You can download the binary by following our installation guide under our wiki. So again, github.com/aws/Copilot CLI/wiki/installation. And just to learn more about the CLI itself, you can go on our wiki page. Thanks for watching.